Then we're gonna walk through it together then. No, but we want to be able to put this into y equals mx plus b. But I mean, for you, Josh, really, you just got to find two things. You got to find the y-intercept. You got to find the slope. And you actually know how to do both those because I tested you on it and you did pretty well. It doesn't look like this, but it was very similar. All right, Randy, let's not do that. All right, so Josh, going to you. I think the easiest part of this, Josh, is to find the y-intercept. So we want to find b. So what would b be?
What? I mean, two.
Hey.
I know it is one because in the other problem it was 6 and now we
Because it correlates with what? You're right. It is going to be 1. But why is it, right, Josh? I have 3 y values. Why did you choose this one?
because the other one was chosen.
It's not the fact that it's you're right. It's not the fact that it's in the middle. It's the fact that x equals 0. You want to find where x equals 0, and that's going to be your y-intercept. So you go to your x column, and you figure out which one equals 0, and then whatever your y value is going to be. So if you rewrite this, it's going to be y equals mx plus 1. And let me get rid of all this green stuff on this side. So there's the table. So if you were to rewrite this, it would be y equals mx plus 1. And then now you got to find your m, which is your slope. And then how would you find slope? Using your what? What's it called? The formula, right? And then what is my formula? All right, now, how do you find that? We're going to need at least, what, 2 or 3 sets of points. We just need how many? We just need 2, right? So which ones do you want to use? You can use any. You have 3 options. Yeah, let's keep them positive, right? And then, which one do you want to make your 2s? Which one do you make your 1s? And really, it doesn't matter, but 1 will make it easier on your subtraction. You'll avoid negative numbers if you make one of them your 2s. Basically, there is no wrong answer. You can choose either the top number to be your 1s or your 2s. Just know that you're subtracting 2 minus 1, right?
So I can do the 0, 1 would be
Whoops.
1 and then 1 again.
Okay, so you'll make those 1s, and then these will be your 2s. Awesome. Now you can just plug it into the slope formula. It's a pretty simple pattern. You're just subtracting up, if that makes sense. So it's going to be like 15 minus 1, and then on the bottom it's going to be 4 minus 0. And then what is 15 minus 2? Or sorry, 15 minus 1? 14, and then 14 minus 0 is?
4.
We can reduce that. Let Josh answer it, guys.
Seriously.
We can actually divide both these by, they're both even, so you can divide them both by 2. Hey, and then 14 divided by 2 is 7. 4 divided by 2 is just 2. So what is my slope? Yep, so if I were to write my equation, it's going to be y equals?
Y equals 7 over 2 plus 2.
Not just plus 1, you're missing one thing. X. Yeah, you're just missing the x. So that is a correct answer.
Well, she need to do 3.5.
You could change it as a decimal. But remember, when you're graphing, fractions are easier because you just count up and over, right? You could do it as a decimal. All right, now example 3. Example 3 is you want to be able to figure out if a graph is linear or if a graph is nonlinear by just a table. So I'm going to do this where it's going to be
You'll 7.
no, I'm going to do this. Okay, so it's going to be
9. Why? 4. Close enough. 4. 9. I don't like negative 0. Well, then get good. And then 4, 2.
whoops. These aren't going to be negative.
4, 2. Oh my goody goody goodness. So annoying, bro.
So you have to be able to figure out, is this graph linear or non-linear? Which means, is it a straight line or non-linear?
Use your big brain, Jason.
So remember that non-linear graphs, they have a y-intercept. Any graph can cross the y-intercept, right? So it doesn't matter if the graph is like a wave. It can still cross the y-intercept, right? So when you have nonlinear graphs, they still have a b. That's what they have in common. But there is something that a linear graph has that a nonlinear graph doesn't. What is it? A slope. So think of it. A slope. A slope. So they both have y-intercepts. They both have a y-intercept. They both have a y-intercept. But only a linear graph will have a slope. For example, if I have this graph right here, which is, it's like a curve, there is no magic number that you just go up, over, right? You can't go up, over, up, over, up, over. It's a different value every time. The stairs are different heights. So it doesn't have a slope. All right, and that's going to be a hint as to how you're going to determine whether this is linear or nonlinear. So, with a hand, who wants to figure it out?
Me.
Randy, was it linear or nonlinear?
I want to say non-linear.
But why?
Because there's not a pattern of both.
There isn't a pattern. Well, I mean, I have, right, that's 5, that's 4, then it's 4, then it's 5, right? So there's not a pattern. This is minus 1, 2, 2, and 1, right? So, yes, Emmy? There are also 2 4s, which means this graph is not a function, but that doesn't matter necessarily. The way that we would want to determine if this is a linear or nonlinear expression is you have to do the slope formula with 2 different points. So, what I'm going to do is I'm going to do the slope formula for those 2 points, right? This will be my y2, my x2, my x1, and my y1. And if I do that slope formula, I get 2 minus 0, 4 minus 0, and I get 2 over 4, and that reduces down to 1/2. All right? Now, I have to choose 2 different points. So I'm going to use this one and this one, right? They're 2 separate points. Yes, this one is being used again, but I'm using another point down here. So this is a completely different formula. This will be my y2 and my x2. This will now be my y1 and my x1. And if I do the formula again with different points, I get 1 over 5. Do my slopes match? No. So if slopes do not match, if it does not have a constant slope, you could also use the word rate. If it does not have a constant slope or rate, it is nonlinear. So this one is nonlinear. All right, now I'm going to give you a tougher one.
Wait, don't.
Oh, sorry.
He said, wait, don't.
Don't you dare.
Oh, yo.
That could be like really bad.
Yeah. I know. It could be something inappropriate. I have no idea. Now I have to learn Mandarin. That's just the bottom line. But is there a difference?
Cantonese and Mandarin?
No. Oh wait, Chinese. She said. Wait, Emmy, did you say Chinese or There's no difference, right?
In what?
Chinese and Mandarin, they're similar. There's,
So
They're-
Mandarin is
they're,
like,
it's like a dialect, right?
like regular Chinese, and Cantonese is
No,
like,
Chinese
they're like,
and Mandarin are the same thing, right?
yeah.
Okay, okay.
I was confused for a second.
Okay. So now, here is another example, and you have to figure out whether it's linear or nonlinear. So, let me think of the points. It's going to be -3, 3, -2, 2, 0, 0, 5, 5, and then 7, 7. So this is an example of, actually no, I'm not even doing that. Don't do the 7, just do the 5s. There you go.
Bro, you made me write
Sorry.
down 10. Pay me money. Literal.
So this graph is a little interesting because obviously there's no pattern on both sides. I did it on purpose. The patterns will not determine whether or not it's linear or nonlinear. You can only use patterns if they both have patterns, right? And these don't. You don't have patterns. This is an example where you got to figure out the slopes of 2 points.
Bro,
When I did the math, and it's non-linear because I said it was going to be linear, so you wanted it to be non-linear.
So regardless of linear or nonlinear, I know that the y-intercept equals what?
0.
Yeah, the y-intercept equals 0 because at 0 equals x, it's 0. Yeah.
you had the 7 instead.
No.
Please.
No.
I don't want to do the 2. Find the slope. I already did.
All right, so someone walk me through how would I find out, Randy?
So I guess we'll do the double point thing.
Okay, which one do you want to use first?
Let's do 0 and 5, 5. 5,
That's-
5 will be our second.
Okay, so this will be y2 and this will
We did
be...
5, 0 minus 5, 0, but it's just 1.
So I'm assuming you're just going to get this right here, 5 over 5, which just equals
1.
1. All right, use another point now.
I'm gonna say negative 2, and 5, 5 again.
Okay, so we're going to use these points again.
5, 5 is gonna be 2.
So it's going to be 5, 5 over 2 minus 2. And actually, it's going to be minus a negative 2, right? It's minus a negative 2, right? So you're technically adding.
3 over 7. That's not a I knew it. I predicted you.
3 over 7.
And is that a linear function? No, they have different slopes, so it's not linear. And this is actually, right here, this is the graph of the, let me try to draw it out. This is the graph of the absolute value of x. And it's that graph that kind of looks like this,
Oh.
where it bends in the middle. So if you used points from here to here, it'd be linear. Or if you used points from here to here, it'd be linear. But is there a constant slope between this graph? No, it's negative, and then it's positive, right? So you would have a slope that is not constant. This is nonlinear, but is it a function?
Yeah.
This is a function because it passes that vertical line test, right? There is not a single point where I can contact the line at 2 different spots. All right, so that was your kind of review for the day. You're going to have an IXL for homework,
What the?
and I'll put it on the board.
We give you this paper, you throw it away.
There's the one shot.
You throw this away, find it.
Put your name on it, turn it in.
I mean, that's just kind of. Bro, no. Oh, wow. So example 4 is on the back, by the way.
That's fine. Name on it, name on it, name on it. Yesums.
Just to say, banana.
This is wrong. I gotta come up.
Sure.